Okay, question 7. So this is the first long question, and I will do the first 3 parts in this video. So we have this situation. There's a windmill. These things are turning around, well, this direction. There is somebody here. Well, there's a guy at point A. I think he's going to walk to point B. This angle is 0.6 radians. Remember, guys, that's important. It's in radians. And it says find the height of point C. So you're effectively trying to find this. Well, let me draw that properly. You're effectively trying to find this height here, like that. C. Now, what you get is a triangle. So we have a triangle there, and I'm trying to find the opposite, because this is a right angle, so we have a right angle triangle. So you could even draw a triangle here if you want, like this. This is 0.6. This is, let's call it H, and this is 12. So if you remember from your SOHCAHTOA, this is opposite, and we have the adjacent, so I'm going to use tan. So tan of 0.6 equals H over 12. H is equal to 12 times tan of 0.6, which is, calculator please, it's in radians, 12 times tan of 0.6, which is 8.20964. 8.20964, which is approximately equal to 8.21 to 3 significant figures, and it's in meters. Fine. Part B. Find the angle of elevation of point C from point B. Now he says he walks 7 meters from A to B. So this here is 7 meters, which means this here, so that's 7, this has to be 5, because that's 7 plus 5 is 12. And then he wants this angle there. So again, I could actually draw another triangle. This is going to be H. This is going to be, that's a right angle there. This is H, which we know to be 8 point, now use this value here, 8.20964. This I know is 5. This, let's call it theta. So now I'm going to say the tan of theta is equal to 8.20964 over 5. And then theta is just the inverse tan of this. Let's write this here. It's the inverse tan of 8.20964 over 5. Press enter. 1.02376. 1.02376, which is approximately equal to 1.02. And this is in radians, so I'll just leave it at that. Okay, that's part A and B done. Part C. This seems to be a bit more tricky. He says, the observer walks until he is directly below the point C. So he's going to be here, directly below the point C. The observer has a height of 1.8 meters and the blades pass 2.5 meters above. Okay, so let's get different colors. Obviously, guys, you don't have different colors, but it'll make it easy for you to see. So this is the guy, he's standing here, and this is his height, and this height is 1.8 meters. And then it says the blades pass 2.5 meters above his head. So from here to here, because the blade is going to go around, let's say there, this is 2.5 meters. Find the length of each blade of the windmill. Right. So this, I believe, isn't actually that difficult. Let's draw a straight line up here. part C. So he's 1.8 meters tall. They pass 2.5 meters above his head. What's left out of this h, which is 8.20964? So I would just say length, L. You could say let length of blade be L. So then L is just equal to the height, which is 8.20964, minus the 2.5 and minus the 1.8. So it's just this, minus this, minus this. And using our calculator, 8.20964 minus 2.5 minus 1.8 gives me 3.90964. 3.90964. And that's meters. Well, let's do approximately equal to 3.91 meters. Okay, that's it. That's part A, B, and C. None of those questions, I think, were particularly difficult. I think the next two parts are more difficult. So I'll see you for part D in the next video.